All right, using logarithms. Let's jump right into this. So a logarithm is the exponent that is applied to a specific base to obtain a given value. Every exponential equation has a logarithmic form and vice versa. So we're going to take a little bit of time to break down this picture. So I want you to notice what is the same on both of them. So probably most notable, the base will always be the base when we're talking about an exponential equation. The base is the number that is below the exponent. It's whatever it has the exponent next to it. Now, in a logarithmic form, the base will be like a sub number. It'll be the log of some value, and then of a is equal to, now that will be equal to an exponent. So we're going to take a little bit of time to break that down. So realize the base, that's probably the best part or the best place to start. And then I guess if we're starting with the exponent or the exponential equation, this is going to switch sides. So that's going to be what we are equal to, and then that a, so that x and that a are going to switch sides. And then to go the other way, I'll show you guys a little trick there as well. So to start off, if we're converting exponential from exponential to logarithmic form, remember, so I just said we're going to start with our base. So that means we would have the log with a base of 2. And these two things are going to kind of switch spots. So the 5 is not next to the 2 anymore. This is going to be on the other side of our equation. And that only leaves 32 to go right here. So we would say log base 2 of 32 is equal to 5. Okay, let's take a look at the next one. So again, take a look at that base. So we have log base 5 is equal to, remember the exponent goes to the other side. So we'd have the log base 5 of 5 is equal to 1. Again, let's take a look. Next one, we'd have 8. Log with a base of 8 is equal to 0. We'd have a 1 right there. And then the very last one, if we're just rewriting these, a log base 5 of 0.04 is equal to -2. Okay, so all we're doing is rewriting these. You can do logs on your calculator. However, your calculator only assumes one type of log, or well, actually two. There's the natural log and a log with a base of 10. So anytime you see a log where they don't give you a base number, so let's say it was just the log of 5. So that is to assume that our base is going to be 10 in this scenario. So we would be able to figure that out based on what we have here. So let's jump into the other way. So we're gonna convert from logs to exponents now. Oh, look, I had that right down there. So again, we start at the base, and this time we have a little trick. So I'm going to write down my 10. Now we loop around, so we go to the other side, and then we come back to 1,000. And this is where it gets a little more understandable, because we can actually check our answers intuitively. Because I know that 10 to the third power equals 1,000, so I know that I'm going to be right here. That's also kind of a nice way to check your logs, is by checking them in exponential form. So again, we go around, start with the base, loop around to the exponent, and that'll give us what that would be equal to. Okay, last, start at the base, loop around to our x, and we come back to 81. So we have 3 to the x power is equal to 81. Now, if I was going to solve that, I would just have to say, well, 3, how many times is 3 multiplied by itself in order to equal 81? That would be x equals 4 if I was going to solve that. That's just a bonus for you. Okay, so like I said, the logarithm with base 10 is called the common log. So that's where they don't have it written out. Even use the same example, that's kind of bizarre. So if you just see log of 5, that base 10 is assumed to be there. And then again, there's another log that we'll talk about later, which is called the natural log. But to finish off this lesson on logarithms, we have the application acidity of water. Because of the phenomenon of acid rain, the acidity of rainwater is important to environmental scientists. The acidity of a liquid is measured in pH, given by the function pH is equal to negative log of hydrogen plus, or a hydrogen ion, where that represents the concentration of hydrogen ions in moles per liter. In 1999, the hydrogen ion concentration of rainwater in western Nevada was found to be approximately, let's see, we got 0.000032 moles per liter. So we got tens, hundreds, thousands, 10,000s, 100,000s, millionths, 10 millionths. So 32 10 millionths per liter, moles per liter. What was the pH of that rainwater? So this looks a lot harder than, it actually is. This is our hydrogen ion concentration. So all we have to do to figure out our pH would be take the negative log of that monstrosity. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 3, 2. And for that, I'm going to use a calculator. So we would get 5.494. Okay, so that's roughly 5.5. Now, I can check that because this is assumed to be a common log. So that would mean that I can take 10 to the negative 5.5, and I can check that. And I get 3.16, so roughly 3.2, and then we get this e -6. That means we're moving our decimal to the left 6 times, so that would be the same as like times 10 to the -6th power. So that would be roughly the same as what we got up here. So there's just a little double checking method right there. So hope you guys learned a little bit about logarithms today. Yeah, enjoy.